Today, we're diving into the world of manufacturing to solve a mystery. We're going to go behind the scenes to uncover how companies make sure the stuff we buy is actually, good. Think of it like a detective story, but our crime scene is a factory floor.
You've been there, right? Why is it that one phone works like a dream for years, but the next one is a total lemon from day one? It's a super frustrating question, and believe me, the answer is not just bad luck.
You guessed it, the answer is hiding in the data. So today, we're going to follow the clues inside an electronics company to see exactly how they use numbers and stats to solve a very real problem: product defects. Let's get our investigation started.
So here's our game plan. First, we'll talk about the why, the quest for quality. Then we'll start gathering our clues, spot the problems, build our case, and finally deliver the verdict. Sound good? Let's go. Okay, first up, the quest for quality. Before we start digging for clues, we really need to understand the motive here. Why does all of this matter so much in the first place? I mean, it's pretty simple, right? In today's market, quality isn't just a nice to have, it's everything. Good quality means happy customers, a successful business, and bad quality? Well, that just leads to a whole lot of waste, unhappy people, and a reputation that's in the gutter. Now, to make sense of all this data, you can't just use a spreadsheet. Quality engineers have some seriously powerful tools. For our investigation, we're looking at the kind of work done with specialized statistical software, which is basically designed to be the ultimate detective's toolkit.
So let's move on to part 2, gathering the clues. And just like any good detective, you've got to prep your evidence. You have to get everything in order before you can even think about solving the case.
And this process really comes down to 3 key steps. First, you just import all the raw data from the production line. Second, and this is super important, you check to see if the data follows that classic bell curve shape, what's called a normal distribution. This step is crucial because it makes sure all our later tests are going to be accurate. And finally, you organize and label everything. I mean, a messy investigation is a failed investigation, right?
All right, our evidence is prepped and ready to go. Now for the really exciting part, spotting the problems. This is where we use the data to find our suspects, those little parts of the production process that are causing all the trouble.
And our number one tool for this is something called a control chart. The best way to think about it is like guardrails on a highway. These charts show you the normal, expected ups and downs of a process. As long as all the data points are cruising between those lines, everything is stable and in control.
And we usually look at 2 main types of charts working together. The X-bar chart keeps an eye on the average of the process. It answers the question, are we hitting our target? Then you've got the R chart, which monitors the range or the variation. It asks, is our process consistent? You really need both to see the whole story.
So here's the bottom line. We scan these charts looking for any dot, any single data point that veers outside those guardrails. Those points are like flashing red lights. They're the clues screaming at us that a machine might be off, or a batch of materials was bad. Something is out of control, and it needs to be investigated right now. Okay, we've spotted some of those flashing red lights. Now what? Well, in Section 4, we're going to see how we go from just finding clues to actually meeting the standard. It's time to build a rock-solid, data-driven case.
And this brings up a much bigger question, doesn't it? I mean, spotting one little error is one thing, but how do we know if our entire process from start to finish is even capable of making products that meet the standards customers demand? Are we actually set up for success, or are we just doomed to fail?
Well, the answer to that comes from a little metric called process capability, or CPK for short. Here's a great way to think about it. Imagine parking a car in a garage. The garage walls are your customer's quality limits, and your car is the actual product you're making. CPK tells you not just if your car fits in the garage, but how much breathing room you have on either side. A high CPK means you're parked perfectly in the middle with tons of space. A low one means you're basically scraping the paint off the walls. Now, in the world of quality control, there's a legendary number. It's the gold standard, a number that everyone strives for, and that number is 6.
This is what's known as 6 Sigma. It's the ultimate goal for a lot of companies. It represents a process that is so unbelievably good, so close to perfect, that it only produces about 3 or 4 defects for every million items made. I mean, think about that. That's just an insane level of quality.
And the final tool for building our case is hypothesis testing. Now, don't let the name scare you. It's basically just a statistical test that lets us prove, with numbers, if our process average is really different from the target we're trying to hit. This takes all the guesswork out of it. It's all about finding statistical proof.
Okay, we've done the analysis, We have our proof. That brings us to our final section, from data to decisions. This is where we put it all together and solve the case for good.
The detective work is officially done. The quality manager now has these beautiful, clear charts and solid numbers. They don't have to guess what's wrong anymore. They can walk out onto that factory floor with a clear, data-backed plan to fix a very specific problem. And that saves time, saves money, and stops thousands of bad products from ever getting to a customer.
And hey, for any of you aspiring data detectives out there, here are a couple of pro tips. First, you gotta understand p-values. Just think of a low p-value, usually 1 under 0.05, as strong evidence. It means your findings are the real deal and probably not just some random fluke. And second, never ever ignore the assumptions. Remember that bell curve test from the beginning? If you skip crucial steps like that, your whole investigation could be completely wrong. So if you walk away with one thing today, let it be this. Statistical quality control is not just about boring math. It's about storytelling. It's about taking millions of meaningless numbers and transforming them into a clear, powerful story that helps companies find problems, fix them, and at the end of the day, make better stuff for all of us.
And that really leaves us with one last thought to chew on. We just saw how a structured, data-driven investigation can totally solve a manufacturing mystery. It really makes you wonder, if this method can perfect a product, what other huge, complicated problems in healthcare, in finance, even in climate science, could we start to solve if we just followed the data?